This video will explain how we use deductive and inductive reasoning to create logos in writing and speaking. When we use deductive reasoning, we're creating something called a logical syllogism. A logical syllogism has three parts: a major premise, a minor premise, and a conclusion or proposition. We're going to look carefully at each of those three parts with an example on the next few slides. Here's an example of a major premise. This is a very simplistic example, just meant to illustrate how this logic works. Unfortunately, we're never going to read anything quite this straightforward and simple when we're actually analyzing deductive reasoning in literature. So here we go. Here's a major premise. Mammals are warm-blooded. Next comes our minor premise. This is the next step in our logical syllogism. And here we have a dog is a mammal. I don't think any of us can disagree with the major premise or minor premise here in this example. We all know that mammals are warm-blooded, and we all know that dogs are mammals. Finally, here's our conclusion. So these are also sometimes called propositions. A dog is warm-blooded. This takes one item from each of the preceding premises and comes to a logical conclusion that if mammals are warm-blooded and a dog is a mammal, then a dog is warm-blooded also. And here we see our whole syllogism on one page. One thing you can notice is that the first item in the major premise essentially becomes the second item in the minor premise. And then these remaining items form our conclusion. The reason that's important is because a syllogism can be invalid if we don't follow that formula. So if you look here at this invalid syllogism, it's if the logic doesn't make sense. So here is a syllogism that is not valid. It doesn't work. Butterflies can fly, birds can fly. Butterflies are birds. Obviously, they're not. And that logic is incredibly flawed, right? We've taken the first item in the major premise, and it doesn't exist at all in the minor premise, and then all of a sudden we're concluding that butterflies are birds. This is an invalid syllogism. A valid syllogism, however, one that the logic actually works in, can still be false if either premise is untrue. So, if I say that the moon is a cookie here, and then I say the cookies are delicious, and then I say that the moon is delicious, I have followed the correct logical pattern, but it doesn't make any sense. Of course, the moon is not a cookie, and maybe you don't even agree the cookies are delicious. So, therefore, this is a false syllogism. It's valid, the logic works, but the premises are not true. Therefore, it's what we call a false syllogism. Don't worry, we're not going to encounter a lot of invalid or false syllogisms this year. I just wanted to point out to you what they are so that when you encounter them elsewhere, you know what you're looking at. So when we use logical syllogisms, we're using deductive reasoning. It starts with general ideas or principles and ends with a specific conclusion. Many of you, when you took the first quiz on deductive reasoning, really got hung up on that particular definition without really understanding what a logical syllogism is. So, yes, we do start with general ideas and get to a specific conclusions, but it's only in this particular format of a logical syllogism. So very generally, frozen things in general are cold, right? And we'll be more specific. We're looking at this particular lake. It's frozen. And so we can conclude very specifically that the water in this lake is cold. The other kind of reasoning that we're going to talk about is inductive reasoning. You use inductive reasoning all the time. It's when we gather specific observations and come to a general conclusion. So I have this little example here from my poor daughter, right? So Vera ate a strawberry. She immediately got hives all over her back. The same thing happened when she was 2. She didn't eat any other foods that are new to her. So I'm gathering all of this information about something I'm witnessing, right? My poor kid broken out in hives after eating a strawberry. And I'm coming to the conclusion that she's still allergic to strawberries. I'm not a doctor. I didn't take her for an allergy test. I don't know for sure. But based on this data I have gathered, it sure seems like this is likely. So my language on that last slide illustrates the key difference, the big, big difference between deductive and inductive reasoning. In inductive reasoning, the example I just gave you, the conclusion is probable or likely, but it doesn't claim to be definitely absolutely true, right? I'm just using maybe common sense. I'm using my powers of observation to come to a likely conclusion. With deductive reasoning, however, if the premises are true, then the conclusion is definitely absolutely true. If I took Vera for an allergy test, that allergy test would operate under deductive reasoning. So let me explain. Just writing allergy test here. If you go for an allergy test, the doctor will say, people who are allergic to strawberries have this particular reaction to this test. He would give her the test. If she had that reaction, then we could conclude that she was allergic to strawberries. That's deductive reasoning. Me just observing different phenomena and coming to a conclusion, that is inductive reasoning. And finally, here is your task. Can you identify the logical syllogism in the preamble of the Declaration of Independence? I'll give you a hint. The conclusion is that the colonists have the right to overthrow the British government. That's the conclusion. See if you can identify the two premises that Jefferson establishes that lead to that conclusion.